Hey everyone, this will be the last video in our chapter about compression, so I'm going to provide a summary of everything we've learned so far, especially in terms of calculation process as well as theoretical knowledge that you'll need to know before you do your exams. Okay, so starting with length versus strength, remember that length is now an important factor. In tension it wasn't. Remember that length, depending on the length of a column, you can have different failure modes and different behaviors. In short ones it's more likely to yield or locally buckle, and in longer columns we expect it to flexurally buckle. Okay, so it's also important to know the difference between real buckling and the one that is modeled by perfect conditions, known as Euler buckling. And when we're looking at capacities, we're always going to be looking at, especially in compression, we're going to be looking at local buckling and flexural buckling. So section capacity versus our member capacity. Okay, so moving on to our design calculations. Remember that we always want our columns or members to have sufficient capacity to support our design loads. So we always want capacity to be greater than our loads. So that's true for both our section capacity and our member capacity. So moving on to our section capacity first, we'll always solve that first in any given question. So NS is equal to KF AG FY. AG and FY can be easily drawn from the one-steel tables, but KF sometimes we might need to solve manually. KF is also in the one-steel tables, but depending on the shape and the question given, you might need to solve it manually. So if you need to solve it manually, your first step is to find the plate slenderness.